Hi dear students, today I am going to explain IB question. Topic is that energy and power. In this question we have a rough ramp and we have two blocks on it, 4 kilogram and 3 kilogram. And question is that when this 4 kilogram it goes to down direction, what's its speed? And we know that if these blocks start to move to the down direction, at the same time second block start to move with it. And this time their speed, they will be equal to each other. And in this question also we have a frictional force for the second blocks, and this frictional force is equal to 3 Newton. And in this solution we must know that conservation law of energy. And conservation law of energy say that energy cannot be created or destroyed. Energy can only transfer from one form to the another. Here, our first block's height will decrease. So it means that its potential energy will decrease. And change in this potential energy, it will transfer to the another type of energy. Firstly, this block's kinetics energy will increase. Some of them, this energy transferred to this kinetics energy. But also second blocks we say that start to move. It will get some speed. That's why its kinetics energy will increase. And also it gets some height, so it has also potential energy. And in opposite direction we have frictional force, so we must do some work against of this frictional force. And in this solving we must accept G as a 10. Now let's start write the equation. Firstly, change in potential energy blocks 4, it will be equal to change in kinetics energy blocks 4 plus, now also second block start to move, that's why change in kinetics energy for 3 blocks 3 plus change in potential energy for blocks 3 plus work here. And we know that potential energy equation is equal to mgh, kinetics energy equation 1/2 mass v squared, this is the speed, and work equation is equal to force times distance and cosine theta. Here we must find it firstly the height for our potential energy, because here we have two potential energy, first and this is the second one. Okay, for the first one height they gave us is 5 meter. Also for second one they gave us that this height is equal to, they say that this distance is 3 and this is the perpendicular. Now we must find that also distance for the force, for the works we need to this distance s, and this distance it will be on the ramp, this s, this distance we need to find it, and according to Pythagoras law we can find it, and this time I can write it s equal to square root 3 square plus 4 square. And the answer is that 5. It means that S it will be equal to the 5. Now we can put the numbers in our equation. Firstly, I will write it potential energy. That's why mass of first block 4 kilogram times G 10 times height 5 meter they gave us. It will be equal to 1/2 mass for the first block 4 kilogram and speed v square. We must find that speed. And also note that first and second blocks speed are the same. And plus 1/2 second block's kinetics energy. That's why it's mass 3 and times v square plus, and now it's potential energy. It's mass 3 times G10 and times distance S. We found that as a it's height for the potential energy 3 meters, and plus frictional force here is equal to 3 Newton, and our distance for this frictional force for these blocks on the distance on the ramp is equal to 5 meters. That's why multiply 5, and cosine here it will be 180 degree. Why? Because movement of the second blocks, it goes to the up direction, okay, but frictional force direction, it will be in opposite direction. So here angle is at 180. Now we can calculate them. For this one the answer is 200. It will be equal to, now for it will be 2v square plus now 3 over 2 v square plus this, it will be 90, and cosine 180, it will be equal to -1, so it will be -15. And now we will add them, and it will be v square, it equal to 125, and here speed, it will be square root of 250 over 7. This is our answer, and speed equal to, for the blocks 4, equal to this answer. And if you have question, you can write your question on comments. Thank you for the listening. Bye bye.